Hello and welcome to today's 35-minute webinar on driving industrial innovation at the edge. Before we start, if you have any questions for us during the session, please use the question button, Q&A button at the bottom of the screen. We'll look at answering these as we go or towards the end of the session. This webinar is recorded and will also be available on demand. Hello, my name is Greg Moore and I'm the Field CTO for the Dell Technology Design Solutions team in EMEA. Today I'm joined with Chris Rommel. He's Executive VP for the Embedded Technology VDC Research, and Inbar Blankenship, Product Management at Rockwell Automation. So let's get started. Manufacturing using digital transformation is driven by new workloads at the edge. These workloads traditionally have started around smart machines. So around 25 years ago, when our design solutions team was created, many of our customers were discussing with us how to take manual production and bring that production into the era of smart machines. Today, that is ramping forward into the smart factory discussions, where we have customers discussing control systems, inventory systems, analytical systems, quality control, etc., and linking them all together to create a smart factory. More often than not nowadays, these smart factories are using artificial intelligence, machine vision, and other advanced systems to integrate these systems together. Today, and going forward, we're seeing a lot more conversation around the smart interconnected factories. This is where our customers are requesting the ability to link multiple locations or multiple factories or multiple elements within a factory complex together to give greater insight into the entire flow of a product from its actual creation to shipping out to the end customer. So to discuss this industrial edge and these connected factories further, I'd like to introduce Chris from VDC.
Thanks a lot, Greg. So as Greg noted, the connected factory is not a new concept. I mean, it's something we've all been talking about for decades at this point. However, the depth of the connectivity and the level of business value that's available from what are now increasingly connected and intelligent systems really continues to accelerate. In our research of product decision makers, 86% of those surveyed stakeholders said that they expect edge capabilities to be deployed with their products in the next 3 years. So clearly, this digital transformation that we're all talking about is impacting all corners of the industrial market. But the potentially impactful outcomes that many organizations are chasing towards that end goal of around some of these end systems, it's not always as easy as you would anticipate, and it takes often the integration of different IT, OT, and sales initiatives if organizations are tying into new service-oriented business models, as an example. So what I'm going to be talking about today is some of the different considerations and factors that you should keep in mind on this journey, and why it becomes important to think about how your upfront partner and product choices can have an impact on every phase of the product lifecycle, both from your design efforts all the way through the deployed lifecycle of those systems. And so in this new edge business dynamic, ultimately, any of these choices you can make or missteps that you might fall into can translate to not only lost opportunities or system performance that maybe is not up to par, but also now increasingly lost revenue opportunities as well. So just quickly, before I go any further, 2 seconds on who I am and who VDC is. We're a leading market research consulting company, and we've been tracking the requirements and preferences of the global product development community for 50 years. And today I'm going to be sharing some results and insight from the research that I do, and specifically results from a survey of over 700 practitioners in the industry, with the hope of offering some insight into some of the leading business and technical trends that are impacting organizations as a way to gain some insight into potential best practices to adapt as we try to best position ourselves in this new edge ecosystem dynamic. So that brings us to a question, with this context that we say, I just said connected factories isn't necessarily new, but why edge? Why now? Why is there all this discussion and hype? And it's really at a point now that it's beyond kind of the hype of old. And really, if you point to one reason why things are changing, and despite motivations around edge deployments varying, it's already that customers are demanding it. In that survey I mentioned, 36% of respondents indicated that they were investing in edge specifically because of customer demands. And what is perhaps an even more pressing need for change is the need to implement new edge projects, is the need to stay relevant and compete with some of your peers. And that in that lens, you can understand how the cost of waiting to change is really growing. And there are a number of levels to that. But again, looking back at that same point of research, we asked why people were moving to the edge. We had about 20% of the respondents also cite the competitive pressure as a primary means for change and for them adapting their solutions. So clearly there's a number of ways why people are recognizing a need to move now. But then if we, I guess just look a bit at what this means, how that translates into how system deployments are changing, over 60% of those same respondents said that they're now implementing additional remote monitoring and control within their industrial systems as I think a great example of the type of change in system intelligence we're seeing. And if we double click on that a bit, we also see that more and more organizations are now enabling services that can improve product lifecycle service and management, inventory management, and also, again, tying back into that revenue generation and finding new ways to generate billable services on top of those product deployments. So when we look at what this means or how these systems are changing, fundamentally now we see software-defined functionality driving system differentiation for many organizations and new workloads that come along with them. But you can see on the chart on the right here that the ecosystem at large is rapidly embracing new feature set goals like machine vision, machine learning, virtualization, among others. And the adoption is already building, but really set to take off in the next 3 years, as you can see here. But that new functionality, those new workloads, they often require new foundational technology choices. In more and more cases, engineering organizations are recognizing the value that commercial solutions can play to allow them to focus their internal resources on ultimately what can be more critical layers of differentiation. So choosing the right partners can help you accelerate the connection, the orchestration, and the innovation around those edge systems as you think about how you're going to compete in this new dynamic. And really, when we look at success criteria around here, and I'll dig into this in a couple of moments, the failure to leverage this, what is becoming a growing third-party ecosystem around the edge, now can cause even greater losses or risk of losses in the future. And I think it really puts the onus on you to think about the technology choices you're making today to enable some of those goals you might have, not only today, but 3 years from now. So when we think about all these changes that we're seeing now, I think it's really important also to think about what this industry has been historically. As much as we can say connected factory is not new and that's a dynamic we've been thinking about, that also speaks to the fact that this industry is one that has traditionally moved quite slowly and made very incremental changes. Many companies in this space are risk averse. You have product development and deployment cycles that are long, and that has often led to a long cycle between making new choices on what type of enabling technology you might have as the building blocks in the different systems you're working on. But the challenges many organizations are facing today necessitate a much faster rate of change than what was okay in the past. The challenges themselves require new considerations around the technology and partner choice as well. Another important piece of context here when we talk about why in many cases the status quo isn't good enough is that already a third of projects are reported as behind schedule. So now you have organizations that by some metrics you can say are failing and you're making their designs more complex. They have richer business goals directly attached to those deployments. And then you start thinking about these other challenges that organizations recognize around edge deployment that really add on additional considerations or needs for their design and development. Manpower and skill set are always something people think about, but now when you think about some of those new workloads I was just pointing at a moment ago, you can understand how there's not only that resource bottleneck to try to work around to help enable focus, but also a need to tap into new skill sets to better enable some of those new workloads that maybe your organization doesn't have a lot of internal expertise to manage. I also mentioned that customer requirements was a big accelerant for change. But it's also, in many cases, can be a big challenge in this industry as well, because very often you need to make very specific and unique design choices or customizations to fit what can be industry specific or customer specific needs. So that in itself can make you want to take a hard look in that context of these challenges we're talking about at other partners to help you navigate and optimize the different solutions you might have underpinning some of those layers of differentiation we discussed. Also, just the core performance requirements facing your designs can be under pressure, or maybe they're just going through the roof in terms of what you're trying to accomplish. So maybe that means you want to integrate new hardware or different acceleration peripherals into your system. Again, making you want to rethink what solutions you're choosing to power them. And let's not forget some of the inherent challenges around security and migrating some legacy technology assets as we try to adapt to this new edge ecosystem. So also an important thing too is you can see how coordinating with external solution providers can be especially challenging in today's environment and make you want to rethink your supply chain strategy as well. Ultimately, this research really just backs up the fact that in many cases, new edge initiatives must be paired with new partners, new tech, and just new thinking about how you bring products to market. So I think, or I hope that I have effectively set the stage here for some of these new edge, about how some of these new edge workloads makes it too hard, or in some cases nearly impossible to effectively scale just in-house efforts alone. It's becoming increasingly critical to identify the right commercial solution partners to help. And really the right technology and paired with the right partner can help a lot. And here's where I'm going to show you a couple of places where we have those proof points. First off, I think we can say here that many of you in the ecosystem are already recognizing this. And we see the percentage of respondents in our research that are expecting to use fully integrated and tested hardware systems expected to more than double in 3 years. Again, with this historical context of how slowly the industry moved, clearly people are very quickly recognizing the value here. And the people taking that leap are really on the right path. Our research showed that people using that type of technology were twice as likely to finish their project ahead of schedule. And our research also highlighted another key strategy organizations can use to get ahead. It's really simple in its premise, and that's tapping outside organizations for help. There was a fourfold improvement in that same rate of finishing ahead of schedule, a fourfold improvement in schedule performance there when using an engineering service partner. So not only can picking the right technology and partner help you establish the type of organizational flexibility and transferable IP that can be helpful, but you can actually accelerate time to market, being able to hopefully generate more revenue sooner and outpacing some of your competitors that are obviously making a lot of progress in parallel here too. So to sum up what I think are the big takeaways from my research in my part of the presentation here, I see three main themes really bubbling up to the top here across design, products, and partner veins. First, from a design perspective, some of these new edge goals require new optimized design for ultimately what are often new software-defined functionality and use cases for some of these systems in the industrial space. Second, when thinking about your products and how to implement some of those designs, you can accelerate your innovation and time to market, ultimately by avoiding some of the in-house issues, whether that's expertise or bottleneck or otherwise, And so to do so, you need to think about choosing enterprise class solutions that can scale and support edge to cloud requirements. And that then has real implications on who you pick from a partner perspective. First of all, you need someone to help you address the unique design and industry requirements that you're navigating. Again, whether you have customer-specific requirements or just trying to meet some of the environmental concerns that you might have. But ultimately, you need to recognize that making the right choices can help you focus on your customer needs and service. And so hopefully that resonates with a lot of you. And I mean, Greg, how well does that align with what you're hearing and seeing and recommending with your customer base?
Yep, thank you, Chris. So yeah, we're seeing a huge amount of growth and discussion right across the spectrum from our customers. Not only just from the information technology point of view, but from the operational technology point of view. And we're seeing, like, believe it or not, many of our customers are still seeing these two worlds or these two functions as separate in their environments. And this is again where we see most of the opportunities for our customers to look at integrating these two environments together. And the discussions we're having right around implementing these projects, designing projects, and supporting the growth in technology and the growth of data specifically in these environments is this creation of, as we've known for many times, IoT for many years now. This has been a buzzword, but where we're actually seeing the biggest change is through this kind of concept of enterprise edge and industrial edge. So we're seeing the IoT spectrum actually growing and changing into these two other areas of focus for our customers. The enterprise edge obviously being kind of the factory-wide type systems where we're taking some of our platforms that would traditionally be seen and used in a data center and now deploying them at the edge. So deploying them in the factory to run the factory locally. The industrial edge then would be the environment at the edge on the production line where we're actually gathering data. And again, that's changing quite a lot. In the past, edge devices would generally have been small PC type systems, where now the big growth in the industrial edge is for more server-based systems. So ruggedized server-based systems that can run more heavy workloads. So analytics, deep learning, machine learning, vision systems, all of these robotics, all of these type of systems there at the edge that traditionally wouldn't have been able to run on a PC class system. So if we look at the opportunities that we're seeing across the spectrum from our customers, we're seeing like these 5 main points are the ones that jump out most from our discussions. The first one is more value. So this is where we're seeing customers analyzing the data sets to see what critical events are happening or potentially could happen. And this is all around what we're seeing, the big growth in digital twin technology. So we have customers who are creating twins of a system, just a smart factory system on its own, or it could be actually a digital twin of multiple systems together to create the factory. And what that allows them to do is actually look forward in time. So create what if scenarios. So what if we have more production or more goods coming in? What if there's an impact in delivery at the other end? What if a production line goes down? How could we dynamically move onto different production lines in the factory? So all of these kind of what ifs can be done by remotely analyzing data sets in a digital twin, and then enabling the operators of the environment to actually see what happens to the rest of the factory when we make these changes. Improved safety is another one. So again, analyzing data, integrating vision systems, CCTV, and tracking systems, for example, where we have robotic systems in the factory or autonomous transport systems in the factory, bringing goods around. Enabling the IT systems to actually sense and detect where people are, so they don't obviously collide. But also just generally, operating the systems in the factory, the machines in the factory, improving safety and ensuring that errors and injuries don't happen. Reducing costs is obviously one of the big ones. Again, all this data flowing in from various different systems, platforms, tracking the temperature of a system, the vibration of the system, the power draw of the system. We can use all of that and analyze that. And when an anomaly happens, so if a particular press or a particular production line starts using more power or generating more heat or more vibration, that is obviously leading to a issue with that line, because it hasn't done it for the last 364 days, so why is it doing it today? So again, that enables the operators to actually do preemptive maintenance and ensure that the factory is maintained potentially while it's online, or actually schedule downtime in a non-important period to fix the issue. Tighter security is another big area. So again, analyzing, storing data and processing data within the factory obviously means that you're not sending that critical data that maybe in industrially sensitive data across the public internet. So where there could be issues for cybersecurity, or maybe just latency or issues in terms of getting data from one area to another. Again, having all of that capability in the factory makes the factory more autonomous in terms of it doesn't need any external access to operate, but also means the data stays locally inside, so it's harder to get at. And then the final thing is faster decisions. So again, using artificial intelligence, to collect more and more data and to analyze what's happening within the factory, or as I mentioned at the very beginning, across smart interconnected factories, so you can see what's actually happening right across the estate. So with our conversations over roughly 25 years of working in this vertical, we have gathered together, lots of conversations, lots of meetings, lots of events that we've had. And these are the 5 key areas that our customers have brought to us. The first one is solutions are often designed by an ecosystem of partners. So what that means is that we're more often than not now, one company or one organization won't be able to supply the full end-to-end solution requirement. And this is where we're seeing, collaboration between various different companies to create the end solution. So obviously, from a Dell Technologies point of view, we have the leading infrastructure solutions right across a number of different verticals, from the edge to core to the cloud. And then obviously we have our customers who add their intellectual property on top of our systems, and then that creates the solution for the end customer. And obviously one example of that is Rockwell Automation that we'll be introducing in a moment. The second area is rugged, rough environments. Again, we're bringing technology that is traditionally in data centers to the edge, so they need to be ruggedized. Longevity and stability. Those kind of tenets are core to what normal factory systems are designed with. IT systems often have a very short life cycle. So again, how do we bridge that gap? And I'll discuss that in a moment. Security threats, again, the more IT we start pushing outside of the data center, the more the risk is potentially there for cyber crime or cyber security threats to happen in those. And the final one then is global agility. This is where this connected factory environment, this requirement for a deployment of systems into multiple locations, maybe in a regionally or nationally or even globally, where all those systems need to be the same. We can't have different systems going to different locations which might have different components in them. So that global agility, that ability to deploy systems consistently and support them consistently globally, is a very, very big consideration. So how do we address some of these? So from the design solutions team, or some of you may have known us by our previous name as the OEM Embedded and Edge team, we have effectively 3 routes to market. The first route is Dell Standard. So that's where we will use our standard Dell Technologies portfolio, the entire portfolio of Dell Technologies, and we will use our unique capabilities and services to help our customers deploy those into the markets they service. So again, that's just using Dell standard off-the-shelf Dell Technology systems. We also have a range of unique systems. These are specialized systems. They are enterprise class, ruggedized systems with long life, and we have options there for branding and rebranding the systems as well, if customers want to show their brand and show their color scheme on the systems that they sell. The final option that we have then is the custom route. So if either of the first two routes to market don't work for our customer or don't fulfill the requirements, we have the capability to actually engineer or re-engineer the platforms that we have. So this could include, for example, more advanced branding. So if you want to have a totally different look and feel to the systems, but more often than not, it's around environmental considerations, electrical considerations, mechanical considerations. So there may be a specific card that's required in a device or in a system to connect to a factory automation system. That card may not be a standard card that we would have in our portfolio. We can validate those cards, test it for power, test it for heat, and ensure that it operates in our system. So part of this is obviously our rugged and rough environments and our longevity. So we have purpose-built platforms, using our enterprise-grade technology that we have tested for many, many different environments. So obviously the environments in industrial and manufacturing locations quite often aren't nice, shiny, clean data centers. So we have things like shock, dust ingress, hot and cold temperatures, water spray, humidity, corrosion, and so on and so forth. So we've tested the various different systems that we'd supply into different environments with these rugged requirements, and quite often we see our customers requiring these to deploy them at the edge. This enables our end-to-end edge portfolio. So starting at the left, we have our edge compute platforms. So this is where we have our small form factor, effectively PC-based systems that can do the aggregation, that they can also do remote management and remote monitoring, or localized management and monitoring for those platforms. We also have the ruggedized grade systems, and we'll discuss one in a moment, but we have a range of rugged servers and rugged laptops and PCs. So again, these are very, very tough industrial grade systems designed to run with very high levels of shock and vibration. And we also have our vertical driven applications. So this is where, for example, we've announced our VxRail D series and also our PowerScale series for storage. And those two specific solutions were designed for the edge. They're designed with small footprint, short depth capabilities and ruggedness built into them to allow them run at these edge systems. And again, in environments where there might not be a traditional data center, we have our micro data center solutions. Underpinning all that, we have our XL and XE capabilities. So XL and XE is the ability or the feature that we have selected platforms in our portfolio that will run for a longer life. So the XL systems specifically for servers, and the XE systems are specifically for client. XL will give you an extra 18 months transition life cycle on the product compared to a standard system, and the XE will give you 9 months extra transition. So that's very, very important, again, for industrial environments where there may be requirements for validation, for testing, for porting of applications, et cetera, et cetera. So giving our customers those extra time at the end of life of a product to maintain delivery of that product to their customers while they do the retesting and revalidation is very important. Again, supporting a lot of that, we have our VMware orchestration and management. And then, if we can't do it, we have a whole capability around our technology, security, and service partnerships that can do global delivery, global technology enhancements, etc. So very, very quick snapshot of the systems from left to right, left being industrial grade to industrial rugged at the right. You can see there, I'm not going to go through all the various different systems, but you can see we have a whole portfolio of capability there. And the key elements would be, the ability for operation in dusty environments through the dust filters, high temperature capabilities, long life capabilities. And specifically there, you can see that there's various systems with various different industry certifications. So you can see some of them have marine certifications, some of them have telco certifications, others have military grade certifications. Again, just showing that these systems are designed for rugged environments. The VxRail D series is a new announcement. This is where we're joining our XR2 server, which is our military grade, our industrial grade, our marine grade server in with our VxRail hyperconverged platform to produce an industry first, which is a full hyperconverged platform with VxRail that can operate in very, very rough, rugged environments. So you can see there, very low and very high temperatures, 40G operational shock. So again, this can operate on vehicles or it can operate right on the factory floor where there's heavy machinery moving around. And also, with high altitudes and also offering short depth, so it can fit into racking environments that would be on the factory floor that might not have the full depth requirements of a normal data center. Number 4 was the security threats. So you can see there we have capabilities right from the edge devices through to the data center, through to the cloud. So we have hardware-based protection. So we have lots of cyber secure technology built into our systems. For example, in the servers, we have secure boot. The systems will only boot using digitally signed Dell hardware or Dell firmware, apologies. We also have dual root of trust. So when the management card and the motherboard are constantly checking each other, so that it's very hard for malware to get into the systems. From the environmental point of view or from the usage point of view, we also have our carbon black capability, which is where we can do full edge to the cloud cybersecurity solutions. And finally, with global agility. So this is where, there's a huge requirement, as I said at the beginning, for these distributed environments. And a lot of our customers operate on this global or national level, at least. So we have, 25 manufacturing locations globally where we can build these systems for local standards. We operate across 165 different countries with 2,200 service centers. And our support teams are supporting, you can see there, 121 million different systems currently supported. So, providing these capabilities and platforms to our customers on a global level is becoming a lot more critical. So what I'd like to do now is I'd like to hand over to Inbar to discuss her perspectives and also how Dell Design Solutions collaborate further with Rockwell Automation. Over to you.
Thanks, Craig. Rockwell Automation is the world's largest company that's dedicated to industrial automation and information solutions, and we do that through what we call the kind of enterprise. We serve a wide range of industries, everything from wastewater to consumer packaged goods to oil and gas. Rockwell employs about 23,000 individuals, serving customers in more than 80 countries, so we really understand that need for globalization. When we look at the industrial automation space, our compute really begins on the manufacturing plant floor. Our programmable logic controllers, or PLCs, take in data from sensors and I/O points along a manufacturing plant line and make decisions on how to operate those machines. The OT control engineers manage and maintain the controllers and their data. That's really where they specialize. As that plant floor looks to aggregate and analyze data from those controllers, data centers such as our IDCs and Versa Virtual Appliance, which you can see is like a layer up, provide that virtual infrastructure that is needed to run multiple applications. Our data centers really represent that convergence of that IT and OT space that we've been seeing become very prevalent. That IT-OT convergence really provides a challenge to our customers. The rapid change in technology in IT and in OT assets that Chris was mentioning, and the increasing complexity in systems, applications, and components provide a gap where the manufacturing floor wants to be able to focus on their application or really line data, but don't have the skills or that staff to be able to manage the needs of the IT infrastructure. And that infrastructure is becoming a lot more important as we look at enhanced cybersecurity risks and the increasing reliance on that network infrastructure and data to enable an operating plant. Industry reports indicate that there's an approximate cost of $20 billion for downtime in industrial automation. And for our customers, 10 minutes of downtime can cost over $10,000. And those downtime costs are escalating. Companies are coming under pressure to improve productivity and address aggressive capacity demands. And these factors are really compounded by the lack of skilled workforce. That rapid pace of change and the IT skill set needed to maintain that infrastructure day to day and along its life cycle is a gap that we help fill so our customers can focus on keeping their lines going. We see that skills gap resonate across the project spectrum when it comes to a virtual infrastructure and the compute. From the engineering to procurement to implementation to day 2 support, many skills are needed to support a data center. Customers who want to design their own need to have someone who's familiar with hardware, someone who's familiar with what virtualization is, someone who has the skills to set up and configure a data center, and along with that, all of the networking, compute, storage, and energy requirements that it takes. And then they need to have the tools and the skills to be able to consistently monitor that infrastructure to ensure that it's optimally running. As Chris mentioned, a third of projects don't meet their time schedule. And when you combine an aggressive time schedule with a lack of skills, you really don't get very good results. Our customers really need a turnkey solution that can provide them a validated, tested, and long-term supported infrastructure. That's really where our data centers and Dell come in. Our IDCs and our Versa virtual products, which provide that virtual turnkey solution for our customers, are based on those XL servers from Dell. These long life servers provide us VM ready nodes that we can use to provide our customers a turnkey solution that helps them meet their IT project schedules. With one of our customers in the food and beverage industry, we were able to deploy our IDCs to over 50 sites worldwide in a schedule that met their production needs. We provide them ongoing management of their virtual environment, including remotely monitor and administer, and we secure the environment with managed deployments of things like OS patching and AV management. That's really necessary for them to achieve a high available infrastructure and avoid that downtime that is so costly and so critical in the manufacturing space. As a project, Rockwell Automation provided the design and implementation of the architecture that we deployed, and our customers were able to see a significant reduction in server issues over the previous IT model that they used. The Dell Solution Group has really helped enable us to provide these solutions to our customers. We're able to create and take to market standard products much faster with their OEM servers. Their global footprint helps us to reach more customers around the world and reduces the complexity for us to manage all of the complications that we see when dealing with our global customers. And honestly, we see a lot of complications. The large portfolio of hardware, software, and services that are offered enable us to create standard products that meet our general market needs, but are also flexible enough to meet the needs of customers who have specific requirements, such as vibration or dust intrusion from their industrial applications. The nice thing is, if Dell can't do it themselves, they partner with a large ecosystem that really expands our ability to meet any need and scale in or out as we need to. And then not lastly, as our customers have a hard time keeping up with the pace of change of technology, we've also had challenges with managing the lifecycle of our products. In OT, a typical lifecycle of a PLC is about 20 to 30 years. And as you know, in an IT space, that's really not very realistic. We're looking at, really more around a 5-year lifecycle. That Excel servers that we use help us provide a buffer for our customers so the pace of change isn't impacting them as hard. Dell also helps us manage our roadmap to be better prepared for those lifecycle changes that come with IT hardware. Even in the past few months, as we've been dealing with the impact of COVID on our supply chains, our OEM account team has really been helping us navigate that ever-changing world and helping us meet the requirements of getting our solutions to our customers globally. So Greg, please make sure you thank them for me.
Yeah, well indeed. Thanks very much. Okay, so moving on to the last section then. So 1 or 2 questions coming in already. One of them is, where we designed industrial rugged systems. I think that's a good example there from Rockwell Automation. in terms of the platforms that we've designed for those and the way we support them. So we look at design solutions and the Dell Technologies capabilities that we have within this group. We work with about 230 plus partners globally. Again, as I mentioned, we operate at the level where we work with customers like Rockwell to create platforms that they will then add their intellectual property on and then sell on to their own customers. So, quite often our systems may not be fully visible in the industrial environment because they might have the brand, as you saw there in some of the pictures. The Rockwell systems weren't branded as Dell. So what we do is we create what we call a design. So we have over 10,000 plus designs that we've created for our customers right across 70 countries and also across 40 verticals. So industrial automation or manufacturing isn't the only vertical we do, but many of the verticals have similar tenets, similar requirements. So what we do is we take customers' intellectual property, such as we discussed there with Rockwell, and we then look at how do we layer the various different services around that or various different capabilities around that. So we have cloud agnostic capabilities, virtualization, hyperconverged, software defined. So we'll evaluate how a customer will bring their intellectual property to market and what the best platform is. The unique kind of elements we bring, though, is we have this dedicated engineering capability. This is where, as I mentioned earlier on, we have the capability of custom designs and unique designs where we can ruggedize systems, create systems for different locations, different capabilities of temperature, vibration, and so on and so forth. But creating the system isn't the only key element. As Invar mentioned, the lifecycle management, the management of a product on a regional or a global basis is just as important. And that program management capability, as you can see there in the top right of the circle, that is a key component that we offer our customers, where we will bring customers right from the inception of a design of a system, right through the process of creating it, creating the first articles, validating those first articles that they're correct and they're operational, and then actually bring them all the way through to certification, global logistics, right through to helping them deploy it if that's a requirement. And what happens then, as I mentioned, the XL and the XE systems, what happens when parts do change? Parts will change over time. So again, the program managers and our team in custom engineering or dedicated engineering, we will help customers look ahead and understand what these changes are and if they are going to impact their system. So that runs on to the next generation of systems when the new system comes out, and we go on and on and on. So it's a cycle, a life cycle that goes on and on. And obviously we have our customization and configuration services to make those systems branded and look and feel as whatever way the end customer wants. And then finally, we have our secure supply chain, which is obviously very important in these days, that we can track and trace all the components in our systems. We have a global reach, as I mentioned already. We have a global support capability, which is specifically designed for customers who are taking our equipment and deploying it as their own. So again, we have the capability of understanding where these systems are deployed. For example, are they in a critical control room or a critical environment where you can't simply just turn them off? So again, we will know what the systems are doing and how they operate from a support point of view. And then finally, we have that full end-to-end capability. So I think before I end, we have a number of questions in the chat box here. So one of them is, let's look here. So how do we see cloud impacting industrial automation? So this is one that is very relevant in these days. There has been a very big cloud first perspective for many companies over many years. And as I mentioned earlier on, we are seeing that cloud first mentality or decision making change to a data first. And big component of that is the reason that data is now becoming the lifeblood of systems. And it's not just a case of trying to shunt it out of the way up to the cloud or onto a remote data center. It's actually becoming part of the environment. And artificial intelligence, machine learning, vision systems in factories, these are all driving huge amounts of data, as we discussed earlier on in this session. So we're seeing that the requirements there are for the data to be local in the environment. So that's driving this data first concept, as I mentioned, where people are now and organizations are now deciding that data needs to sit very close to where the analytics is happening and the decision making is happening, which again now is driving the requirement for these short depth rugged systems that we're deploying in factories. I was on a customer call there during the week, and a very good analogy was given to me, which I think is very relevant. That, you know, if you're driving in your car and you have a misfortune, an accident, and the airbag goes off, where do you want the intelligence to run your airbag to sit? Would you like the airbag intelligence to be in the car so it can do really low latency instant deployment of the airbag? Or do you want the airbag intelligence to be in some distant location in a different country? So, you know, by the time the response comes back, it could be too late for the incident. So I think that was a good analogy to show where latency and the importance of having the decision very close to where the data is generated is a very important one. And the final question I see here, just scroll down, just conscious of time. What's the biggest challenge that we see in manufacturing? I would nearly say very similar answer to that one again. It's data. It's how do we store data in factories? One of our other customers is one of the leaders in robotic systems in automated transport of goods around a factory. And their robot systems are generating terabytes of data a day, for example, just on those systems in terms of the LiDAR and the management and the data that they're collecting as they're moving around. So again, I think data would still be the biggest challenge we're seeing in manufacturing and controlling that data. All right, so I don't think there's a number of other questions there, but I think we're running short of time. So what I'd like to do next is just put a poll up. So would you like us to connect with you to help design your solutions and talk further around how industrial automation is going? There's basically yes or not now. We'd like you to put your answers into the Q&A window, please, if at all possible. And if there's any other Q&A questions there, we're happy to answer them in the final couple of minutes of this webinar. So on that, if there's no other questions, I'll just give a few more moments for people to give us their yes or no, answer one or two into the question Q&A area. And if there's no other questions, we'll end it there. So thank you for your time today. I hope the discussion we had across the three speakers was of interest, and we look forward to seeing you in our next webinar. Thank you very much. Take care and be safe.